Hello everyone, I am Nikhil. So today we have to discuss a topic about deep learning. In that, the concept about the visual similarity recommendation systems using the generative adversarial tech networks. Um, let's move on to this topic. This presentation explores the development of a visual similarities recommendation systems that can be provided by the generative advantage networks that will be develop the challenges and recommending visual similarities items that can be architecture of our purpose gen-based systems and it potential applications in the e-commerce. Let's move on to the introduction of the generative advanced networks of GANs. And it has the two networks and advanced serial training and the data analytics. The GANs consist of the two neural networks generate and discriminations. And in advanced serial trainings, the generator learns to create a realistic data while the deterministic aims to distinguish the real data from the generated data. The next one is a data synthesis. Uh, it is also known as generate the data from the training data set. The next one is the challenges in the visual similarities recommendation. In that we have the four. In that the visual diversity and the fine grainity difference and the data scarcity, and the next one is the contextual factors. In that we have the visual diversity. The images are very greatly in style, perspective, and the equality, making it hard to find the truly similar items. And the next one is the finer grained differences. In that we have the small visual differences can be significant effect that can be provide the similarities. And the next one is the data scarcity. It can be building a robust recommendation systems by requires a large data sets of visual similar products. In the next one is a contextual factors. It can be used as the preferences that can be purchased, the histories and their influences similarities. The purpose of a GAN-based recommendation systems in generator networks and discriminator networks. It have a generator networks to learns the create the synthetic images that can be resemble the real product images in the training dataset. And the discriminator networks having the discriminator networks that can be acts as a evaluator that can be distinguished between the real product images and the synthetic images that can be generated by the generator. The next one is the data pre-processing and normalizations. In that we have the image resizing and data augmentations and normalization. The images can be resized that can be considered the size to ensure the uniformity in the dataset. The next one is the data augmentations. In this technology, we can like rotations, flipping, and the color adjustments are applied to the increase the data university. And the next one is the normalizations. In that we have the pixel values to scale it up the specific ranges from the 0 to 1, improving the training efficiency. The next one is the discriminator and the generator networks architecture. In that we have the discriminator and the generator. The discriminator that can be typically employs the convolutional layer to the extract features from the input devices, and the generator networks having the generator network that can be mainly focusing on the generating the realistic images from the random noise. And its architecture often involves the transferring evaluation and conventional layers is also known as deconventional layers, which can be a sample that input noise are gradually created by the higher resolution image. In that we have the advanced serial training process. In that we have the generator training and the feedback loop. And the next one having the discriminator training. The generator training, the training that can be learned to create the synthetic images that can be resembles and the real product images. And the next one is the discriminator feedback helps the generator improves the image generation capabilities. And the discriminator training, the discriminator learns to distinguish the real product images from the generated images. And the next one is a evaluation metrics and benchmarking. In that we have the precision, and the second one is recall and mean average precisions and the featured inflection distances. The next one is the deployment and integrations with the e-commerce platforms. In that we have the research results, product detailed pages and personality recommendations. In that we have the research search results from the recommending the visually similar items such as helping to users to discover the related products. And the product details pages, it can be helps to discover there are just a visual similar items on the detail pages and encouraging the sale cross sellings. And the next one is the personalized recommendations. It can be used for the delivery visual relevance or recommendations to browsing their histories and purchasing, enhancing the user experience. And the next one is the conclusions and the future directions. In that we have the improved the data quality and in expanding the training data sets with the diverse and high quality images that can be crucially for the enhancing recommendations insurance or accuracy. And the next one is the advanced JIN architecture. It can be used to explore the complex JIN architectures that can be potentially leads to a more refining visually similarities and analysis. And the next one is the user feedback integrations. It can be incorporating the users and feedbacks and preferences that can be recommending the systems that can be personalizes that results and the user satisfaction. In the conclusion, we have the discuss about the improve the qualities and their advantages and their feedbacks integrations. So thank you for watching this video.